Hello students, today's online session we will learn the eighth program, that is use the Naïve Bayes classifier to classify the data set. That is on any standard data set you need to apply this Naïve Bayes classifier. Naïve Bayes classifier which is imported or down, that is a function. You can use it as a function which is present already in the Python library. Now, Naïve Bayes classifier. Naïve Bayes algorithm, it is a supervised learning algorithm which is based on the Bayes theorem, which you will be learning in your theory session. And this theorem, we use it for solving the classification problems like your decision tree. Decision tree, we use it for solving classification and regression problems. Bayes theorem, we can use it for solving the classification problems. And here mainly we do the text classification, and that includes a high dimensional training data set. Why do we call it as naive? It is called naive because it assumes the occurrence of a certain feature is independent of the occurrence of the other features. That is, it predicts that a particular feature does not depend on other features. Like for example, if you have a fruit which has been identified based on the attributes like color, shape, taste, etc., then you can say that a fruit which is red in color, spherical in shape, and sweet, and it is sweet, you can recognize it as an apple. Hence, each feature individually contributes to identify that it is an apple without depending on each other. That is a simple example. Now, Bayes it is called Bayes because it depends on the principle of Bayes theorem. This principle of Bayes theorem can be given using this formula, that is probability of A given B is equal to probability of B given A into probability of A divided by probability of B. This is the basic Bayes rule or Bayes law. Now we will see how we will implement it. Let us train the data set using this Bayes, Naïve Bayes. In order to implement as program, the steps we need to follow are: first is data pre-processing step. That is, we'll download what all libraries are required from the Python library, and then fitting the Naïve Bayes to the training set. After that, predicting the test result, and then finding the test accuracy of the result using the creation of confusion matrix. Again, this is a module under sklearn. All this we will import and use it in the program. And then you can visualize the test set result. So these are the steps to implement the Naïve Bayes into the data set. In data pre-processing, we will import all the Python libraries whichever is required for the program. See, this is your program code where you will import. First thing that you will import is pandas as PD, and then you will import modules like train, test, split, standard scalar, Gaussian NB, and confusion matrix from sklearn.model selection, sklearn.preprocessing, sklearn.Naïve Bayes, and sklearn.metrics. So these are the functions present within this library, that is sklearn. Under model selection, you have this train underscore test split. You are importing all these functions from the Python library in order to use it in your program. Next, Once if the data pre-processing is done, importing the next step is to importing the data set. The data set which we will be using in this program is user underscore data dot csv. As I told you in the last lab, whenever you are using some csv dot the dataset dot csv files, you have to make sure that both your Python program and the Excel Microsoft Excel document is present in the same folder. See, in the desktop under program 8 I have saved both these files so that directly you can execute the program. You are reading the CSV file user underscore data dot CSV using the pandas module pd dot read underscore CSV. This is the rule for reading the user underscore data dot CSV file. Bringing it in is equal to data set, an object you are creating called data set for this Excel file. Next, what you are doing is, after this is done, you are going to split, that is dataset dot iLocation of. This will come under the pandas library, where it will select the row and the column values, and it is stored into X. Now here, see, it is mentioned as colon. Colon means it will consider the row from the beginning till the end, comma, the columns. It will consider the columns 2 and 3. For example, see to the code here. This is your X value. To the X value, you are selecting entire row. For example, see, this is your file. Dotted means all n number of files are, a total 400 rows are there. So entire 400 row it will select. That is colon means from beginning till the end, the rows. And then 2 comma 3, the columns 2 and 3 will be selected. That is, this is a 0th column, first column, second column and third column. So 2, second column, that is age and estimated salary. Third column, that is salary, will be selected as X, and Y. Y usually it is the value, prediction value, right? So Y here, entire, again the entire row, comma, the column 4. The fourth column is purchased. 0, 1. Purchased value, if you see, you can see that it is either 0 or 1. 0 means no, and 1 means it is yes, it is purchased. So based on these two attributes, the column attributes age and estimated salary, you will predict this purchased, whether a person has purchased the product or not. Now here next you are giving a print of data set. This print of data set will print the entire data set which is read from the user underscore data dot CSV. So this is your print of data set. It will display all the data set. So you have total of 400 rows and 5 columns. These are the 5 columns. 3 plus 2, 5 columns it has read from the user underscore data dot CSV. Now, how do you download this user underscore data dot CSV? Go to the internet, either from the GitHub or this one kaggle.com. You can easily download this file, which is freely available, and you can use it in your programs. So this printf, hope you are clear. This is it, printing the values in your user.csv. Yes. Next, what you are doing is you are splitting the data into train data set and test data set. How do you split the data? Using train underscore test underscore split off function, where you will get this train underscore test dot split off function, which comes under the Python library sklearn.model_selection. So inside this, what you have to specify? You have to specify the parameters x, y, and the test size you are going to specify. Here the test size you are specifying it as 0.25. That means 25% of the data set you are using it for testing, and the rest 75% of the data set you are using it for training. Now one more function you are assigning it into SC. It is nothing but standard scalar of. Standard scalar of belongs to the library sklearn.preprocessing. That is a pre-processing function, standard scalar. This pre-processing function, what it will do is it will remove the mean and it will scale to the unit variance. Now using this SC variable or the object, you are fit underscore transform of. You are transforming it. What you are transforming? X underscore train data set. You are fitting it into X underscore train. You are doing the transformation and saving it in X underscore train. Same way, X underscore test SC dot transform of, you are saving it to X underscore test. This is a pre-processing procedure. You're doing the pre-processing step. Next, after that, yeah, we are done with feature scaling. Scaling is done. Next, what you have to do is you are fitting the Naïve Bayes to the training set. Now your training set split up, everything is ready. Now you have to apply the Naïve Bayes to the training set. How you can apply the Naïve Bayes to the training set? From the sklearn.Naïve Bayes, you are going to import the Gaussian NB function. Thus, you are storing it into the classifier object and use this classifier as object to train. That is dot classifier dot fit of x underscore train comma x underscore y underscore train. You are fitting it or teaching the model, that is x underscore train and y underscore train. Next, what you have to do is you are going to predict the test set result. In order to predict the test set result, using this object, that is classifier, you are calling the function predict of x underscore test. That is on the test data, that is 25% you have kept for testing. In order to consider it as test data set, right? On that, you are applying the predictor. Now, from where you will get this? Yeah, you are predicting the here you in your data set you are predicting the fourth column, that is purchased, yes or no you are predicting. Yeah, so using the learning, the model is being learned using the Naïve Bayes, right? You have trained the model using Naïve Bayes. Now after training you are performing the predict on the X test and then you are storing it into Y predict variable. Next, what you will do, you have to check the accuracy of the prediction. In order to check the accuracy of the prediction, you can use this confusion matrix. This confusion matrix function comes under the Python library sklearn.matrix. Under sklearn.matrix, you can import this confusion matrix, which will show the accuracy of the predicted value. Now, you are applying confusion matrix of to the y underscore test, the actual values from your data set, comma y underscore predict. Y underscore predict is nothing but using this classification, you have predicted the value of the you have predicted the value, that is yes or no values using the x underscore test data set. So that is your y underscore predict. So if this model has to be 100% accurate, this both should be equal, right? The actual value and the predicted value should be very much equal. That means it is, if it is 100% equal, then you can say that it is a perfect model. Now, other than that, you can say it is a, here you will get it as a good model. Now, this confusion matrix value, you are storing it to CM and you can print the CM value. That is the confusion matrix. You can see the confusion matrix shown here. Now, in this confusion matrix, this 7 plus 3 is the incorrect predictions and 65 plus 25, that is 90, is the correct predictions. That means it is a good model. Now in the program, the see here, the classifier is equal to version NB of the, using this object, you are calling fit of x train comma y train, and then your classifier, you are predicting using the classifier module object, you are predicting predicting x test value and putting it into y predict, and using the confusion matrix you are checking the accuracy of the model, and you are passing the parameters y test and y predict as parameters. You are passing it, and the result you are storing it in CM, the variable CM. Now you can check the result by printing the CM, that is confusion matrix. Here you can see the confusion matrix being printed in your output. 65, 3, 7, 25. This is your confusion matrix. So this is your Naïve Bayes program. And in order to execute this program, you have to store this user underscore data.csv in the same folder where this Bayes.py is py is stored. Your Python file is stored. And this print of data set will print these values into your output. The data values from the file it will print here. This plus it will show you how many rows, total number of rows, and how many, what are the total number of columns it has printed. And then next, here one more print you are using, that is the confusion matrix you are printing, which is this, the confusion matrix. So once if you type this program, click on this run button, you will get this output. This is your output. So this program, you need to write it into your record along with this output. Before that, you have to execute the program, and then only you should write it into your record along with the output. I will upload this session along with the PPT for explanation, and the Word document I will upload, which will consist of your program along with the output for your reference. Thank you, students.